All right, for today, this is about absolute values. I hope you remember the basics of absolute values, but I have realized that there's usually a few people that have even forgotten the basics. This is not the basics. That's the more advanced, actually, but let's talk about the basics for a minute. An absolute value, if you graphed it, what shape does it make? A V shape. So if I said the absolute value of -3, is that a V shape? No. The absolute value of -3, what does that mean? Right off of the ACT's list of things you have to know is understand absolute value in the context of distance. Do you know? Maybe. Raise your hand if you can explain this in the context of distance. Yes?
The absolute value of 3 is 3
No, this is -3.
Or -3 is 3 units away from the origin in both directions.
Oh, you had to say the origin to make it sound all fancy. All right, so it is a distance of 3 from 0. Because, just to clarify, we aren't in 2 dimensionals right now, and therefore that's not really the origin. It's just a 0, and yeah, the distance that it's away from 0. So what is the distance that is away from 0? It's 3. And how about the number 3? What is the distance that is away from 0? Well, it's 3. All right, so then how about this? What if I say absolute value of x is 3? That's a different question. In the context of distance, what is that? Well, we don't know what x is, right? So go ahead, what do you think?
It'd be like, what could x equal to be 3 units away from 0?
Very good, I like it. What could x be so that its distance would be 3 away from 0? So this is the distance each time. All right. And now I'm going to write a different one. What about x plus 2 equals 3? Do you get that each time that's always been the distance? It's still the distance. All right. I'm going to change one little thing. I think you'll understand this better if I use a minus here just for now. A -2. So everybody change that to a -2. Well, how about this? Let's get the answers. You guys will know this better once we see the answers. Would you agree it's x minus 2 equals 3 and x minus 2 equals -3? Remember that? That's top 20, and the reason it's there is so that on a day like this, we can delve into the deeper stuff, not just the simple, grinded out 5 and -1. Okay, so the answers are 5 and -1. So what's the question? I know, it was x minus 2, absolute value equals 3, but what's the question in the context of distance? I think you can do it, but I don't want to call on you yet, because I think other kids can do it too if you give them a second. If the answer is 5 and -1, what was the question? Three people's hands popped up. That was good. Give it a little bit of time. What's the question? If the answer is 5 and -1, what about distance? All right, back row there.
So x, like both x and like 5 and -1.
Yep, these are the answers.
From
They are what away?
3.
They are a distance of 3 units away from the 2. Let's look at it on a number line. I'll make a number line quick. Here's a 2. Let's say I go 3 units this way. What's that? 5. Let's say I go 3 units that way. What's that? -1. Look at that. These are the things that are 3 units away from 2. Good job. Okay. So, what if I said this? The question really is, what are things that are how far away? 1 unit away from 9. And so I bet you can tell me the answers. 10 and 8. All right. Now, I'm just trying to tell you that to show you kind of a context for distance and absolute value. I'm going to give you one more example of that. This is going to annoy you a little bit, but just think about it this way. Do you get these are the things that are 9 away from 0? See? So do we have to say x minus 0? No. If I'd have just said this at the beginning of the hour, we were talking about how it was 9 away from 0. See, if I draw it at minus 0 here, it kind of shows you that those are the things that are 9 away from 0. All right, one last little twist. These are not the things that are 3 away from 5. They're the things that are 3 away from negative 5. All right. So here's negative 5. And then here's negative 6, 7, 8. 4, 3, 2. Would negative 2 and negative 8 fit the bill? All right. I think you got some context now. So now we have to move up and talk about deeper stuff. Just making sure we're going to get to this page. So they're saying that there are properties of absolute values. One of them is that if there is a multiplication of two things, you can split them into two separate absolute values. You see that? So if I had absolute value of 40, I could break it into the absolute value of 4 and the absolute value of 10 being multiplied. Does that make sense? Okay. Another property is the power rule. Basically, if it is something squared, like for instance, absolute value of 5 squared, that's the same as absolute value of 5, but squaring it on the outside. It does say whenever a to the n is defined, meaning if there's no such thing as 5 to the second, then this wouldn't work. All right, how about this one? Basically saying if you want to break up divide into, break up multiply into something times something, you can break up divide into something divided by something, provided that b is not equal to 0, because you can't have a 0 on the bottom. All right. And what are some other properties? This can be 0 if and only if x is 0. It seems pretty obvious, but mathematicians are really careful to define everything. So they had to cover equals 0. But then how about, can it be a positive answer? Yes. Then x is c and negative c. That's what we've been doing all along. But wait, this last case. What if c, which is no solution? What if c is the number outside is less than 0, there's no solution? I never did one like this, but what if I had said, no, not y equals, sorry. Absolute value of x plus 4 has to be negative 2. How could you be a distance of negative 2 away from something when distance is defined as being positive? Another way to say it is absolute values can't come out negative, so no solution. That make sense? And do you get it's really easy when you're just kind of in the mood of okay, so I'm splitting this into two equations. X plus 4 is negative 2, and x plus 4 is positive 2. You'd never even know that you just did something that's impossible. Because you go on and solve it, and you get two answers. But they're useless answers, because when you put them back in, they wouldn't work. It's kind of like saying the square root of x minus 5 is negative 4. Can you start just by squaring both sides? Well, you normally would, but why can't you in this case? Square roots can't come out to be negatives unless you want an answer in the complex numbers system. All right, so bottom line, if you ever see an absolute value coming out to a negative, danger, it's a trap. All right, no solution. Okay, moving on. Here, I think we have to solve each of these. This is the part where I'm hoping you're good up until you hit number 5, and then it's going to get weird. Everybody do 1, 2, 3, and 4. Actually, you know what? We'll save some time. Skip 4. Just do 1, 2, and 3. And I'm going to pause for a minute. I'll do them also. Look up at the board when you're done. Okay, if I could turn your attention to problem 3 for a minute. I'm at this point where I've got this fraction. And even though I can do fractions, I don't like fractions. How do I get it out of there? This is clear fractions right off the top 20. Times by 3. But if I just do it on one thing here, you wouldn't want to just go the 3 times the 2x. You got to do 3 times all of it, so you're going to distribute it. So I'm going to just go a 3 times this and a 3 times that. So this is 6x plus 3 equals 5. A lot of people forget and don't multiply one of the pieces by 3. 6x plus 3 equals negative 5. So I got 1/3 and negative 4/3 at the end there. Can anybody verify those numbers? You got the same thing? Okay, good. All right, checking back on problem 2, negative 3 and negative 7. And on problem 1, 7/3 and negative 5/3. Anybody verify those? Okay, good. All right, now I want to stop for a second and say, there would have been another way to do this. And it would have been a method that I've told you guys is very powerful. It's not if you can factor it, you should. There wasn't any factoring that I could do to solve this. Let's see if anybody can pull it up out of memory banks. Awesome. You proved my point that nobody remembers this awesome strategy, and I would remind you later that I had told you about this and that nobody will remember it. You can graph both sides and see where they cross. It's just not on the radar for most people. Do you get this as a V shape? Do you get this as a straight line? If I graph y equals this V shape and y equals 6, they will cross exactly at 7/3 and negative 5/3. I could graph this, even though it's not quite as clean, y equals all that, and y equals that. And do you get this? These kind of take a long time to solve. There's a chance that typing into your calculator, since it's y equals, they're both y equals. They're already solved for y. This might be one of those times where typing in the calculator is faster. You know what I mean? Just type in y equals this, y equals that, see where they cross. And that to find out the exact spots, since a lot of times these were decimals, you would want to know how to do second calculate intersect. But in this case, you could have even just visually seen, oh, they're touching at negative 3 and negative 7. One last time to show you what I'm talking about here. Imagine that you had this. Do you get a line at y equals 2x plus 1? Wouldn't be too hard to do. Except I went through 0. Try again. There. And then a line at y equals 8 wouldn't be too hard to do. And wherever they cross, that's the answer. But wait, that would have been not a V shape. What happened? What went wrong? I graphed just without the absolute values. See what I'm saying? If I had done it with true absolute value, that's a V shape that's been moved one to the left and vertically stretched. So let's say it's something like this-ish. And then my y equals 8 goes through like this, and I get my 2 answers just like I'm supposed to. Make sense? Okay, so that is one of those strategies that's so easy to forget. If you ever get stumped on a tough equation, but you're allowed to use a calculator, which is true on the whole ACT, for example, if they're solved for y, like these are, you can just put y equals this, y equals that, see where they cross. Okay. A couple that were tough, and I should go back to those just a second here. Yeah. Number 5, it gets strange. but you still trust our process, which is to break it into two parts. Let's just act like it's a normal problem, and then we'll deal with it when it gets strange. Got two parts. X equals x squared minus 6, and x equals, what, should I just pick one of them and make it negative? No. Parenthesis around it. Distribute that negative. You'll have negative x squared plus 6. Doesn't that look like a couple of quadratics? So first step, you set them equal to 0, and then if you can factor it, you should. What if you can't factor it? What still solves quadratics? It's a quadratic formula. All right. So let's set these equal to 0 and solve them. Everybody give it a shot. Sometimes they'll factor, sometimes they won't. Usually they'll factor. Don't forget, set it equal to 0 or this doesn't work. Save us some time. Somebody must have figured it out. X plus what? X minus what? X minus 3, x plus 2. Very good. That makes negative 6, and yet the inside and the outside make negative 1x. Yay, you found it. All right. Now, on this one, I want to draw your attention to our negative x squared plus 6. And I'm going to subtract x from both sides, and then I get negative x squared minus x plus 6. A little trick, little pro tip, factor out the negative 1 and then try to factor it. Take negative 1 out first. And then you get x squared plus x minus 6. Much easier to factor than trying to drag around a negative x all over the place. Okay, so just factor out a negative 1 when you have a lead coefficient that's negative. And still 3 and 2 to make a 6. And then I just got to figure out which one in this case to make positive. This time I'll make the 3 positive and the 2 negative. There we go. X equals negative 3 and x equals 2. So wait a minute. You're saying there's 4 answers to this? Could there be 4 answers to this? I want you to look at what the graph would look like. And then I want you to tell me whether you think there's 4 answers to this. Would you agree it's a V shape for the absolute value? Absolute value looks like this. The other one's a quadratic. Is there any way I can draw that quadratic so this is going to have 4 intersection points? It's x squared minus 6. How do I graph x squared minus 6? It's a parabola that's been shifted down 6. Would you agree it's going to touch, but it's only going to touch twice? So what just happened? Have you ever had a situation where you get answers and then they just don't work? Do you remember the name for them? Extraneous. So then we've got 4 answers here, and we better check which ones of them actually work. All right, so I got 4 answers. Negative 3, positive 2, negative 2, and positive 3. I'm not sure which ones of them work, so I'm going to test them. Let's put in 3. Everybody put in 3 quick. Does it work? Is that true? Yes, so it appears that 3 works. Okay. How about 2? Plain old-fashioned 2. What? We solved it. We got 2. You're telling me it doesn't work? Why doesn't it work? Because the absolute value of 2 is not -2, is it? All right. This is one of those moments where in math, it's a good thing we had 2 methods. The graphing it thing made me think, let me just check this because I got 4 answers and that seems weird to me. And I check it and I like make a quick sketch of it. And I go, wait a minute, there's only going to be 2 spots where this hits. Ooh, there's extraneous solutions. All right. So what's the moral of the story? When you only have like 9 questions on a test, 4R3s, 4R2s, you have time to check them to make sure they work? Okay. Are there some times that it's more likely than others that you might run into danger? Yes. Whenever you have square roots, because then square roots can be negative and then things don't work right. Or when you have absolute values, because absolute values aren't supposed to come out negative. You know what I mean? So there are times, and absolute values is one of them, where you got to really kind of watch close. Be like the guy going through the security line with really baggy pants. Like it looks like there's something strapped to his legs. Maybe we'll just let him go through. Nah, maybe we should pull him aside and say, why are your thighs 3 times the size of everybody else's? Oh, those are bags of powder that are strapped to your legs. Okay. Baking powder, that's what people like to smuggle. Okay, so if I were starting this one, I would subtract 1 from both sides. But I'd like you to tell me what you think should happen next. Write out your 2 equations that we would have to solve. I know this is going to happen to people. I just made a subtle mistake. Can you catch it? I said x minus 2 equals x minus 1. And I said x minus 2 equals negative x minus 1. Yes? Yes. On the right-hand side, when I made this side opposite of, I should have put a parenthesis around that to make sure I distributed the negative to both parts. So bottom line, it's negative x plus 1. That's all it would take. Now, after having recently been reminded that weird things can happen with these, something weird's going to happen. If I wanted to solve this, couldn't I take away x from both sides? And I'd have negative 2 equals negative 1. What? Is negative 2 equal to negative 1? Nope. What does that mean? There's just no solution on that side. Does that mean that the whole problem is crashed and burned? No. Just that side doesn't have any answer. Let's see if the other side has an answer. Actually, I don't really want to add 2 there. I want to add x on both sides, personally. Yay, I got at least one answer. And it's 1.5. But things that were weird enough that I would take a second and check it. I'm going to go back and put 1.5 here and 1.5 here and see if it's really true. 1.5 minus 2 is negative 1/2. Absolute value of that is 1/2. Plus 1 is 1.5. Yay, that does work. That make sense to you? All right. One more time. If I had solved a equation and I'd gotten like at the end of it 0 equals 4, there's no solution. What if you solve an equation and it's like 4 equals 4? what's that mean for the answer? Is that also no solution? Yes? It's all reals. Very good. Can you think about a situation where if you had it graph-wise, how could you have an answer of all reals? What if I said, where does this overlap with this? Everywhere. All right. Oh, here the homework starts. This is just moving on. Take a look at this. Oh, wait a minute. I skipped. Moving on. There's one more weirdness we need to handle. And this page is one we were on, but let's back up a little bit and show you considered notes right there. Yep. Let's go to, we're going to do that. That's where it starts right there on the orange one. We don't need to do all of those because if you can do 5, you can do all of the rest of them. So we're going to just do number 5. Next, on the green page, we do need to talk about some quadratic ones. I think we should do all 3 of these, but danger. Check your answers. Remember how I came up with 4 one time where we knew that was not possible? Okay, so do these 3. This page, it's in the homework. Look at number 16. It's an absolute value equals an absolute value. Ew. What do you do when there's absolute value on both sides? Well, hint, give up. Yeah, great plan. All right. Would you agree that's a V shape?
Yeah.
Would you agree that's a V shape?
Yeah.
Could they intersect?
Yeah.
Could they get in a situation where the 2 V shapes never touch? Is that possible? Yeah, it is possible. You have one that's like narrow and one that's wide, for instance. Those V's would never touch, right? And there's a lot of ways you could never touch. Is it possible that they could touch twice? Yeah, I get another V shape that's like this, and all of a sudden they touch twice. Is it possible that they could be right on top of each other and touch everywhere? Yes. Okay, I don't like my analogy anymore. Okay, so anyway, I'd like you to set up the equation for this. 3x minus 2 equals 2x plus 7. Oh, can't even write anymore. And then the other side, 3x minus 2 equals negative 2x plus 7. And then there's actually 4 cases that we have to check into. Because this side has its V split. And then we'd also have to do the other 2. Which is if this side gets split into 2 parts. So we'll have 4 equations. But in the end, we've proven because they're V-shapes, that the most answers that there could be would be 2, unless they happen to overlap everywhere. Yes?
Shouldn't they technically, like, only overlap on one side if the...
Yes, there could be one answer. I just said the most answers that there would be is 2. Go ahead. Keep talking.
So if you shift it, like, up and to the right, like that, and then you just have, like, the regular one, wouldn't they only intersect on one side?
Yes, you can absolutely get only one. You can have a situation where there's one solution. But I showed you before that there's ways you could get 2 solutions, right? Okay, so you're right that sometimes you're going to get 1 solution. Sometimes you're going to get no solutions. Sometimes you're going to get 2 solutions. But if you ever got 4 solutions, you should be suspicious. Yes?
So if you had the, like, regular, like...
Come and draw this.
Like, couldn't it...
Draw one that you think might intersect more than 2 times.
Couldn't it do, like... Sorry.
Maybe you're onto something.
Like... that?
Okay, good question. So he just came up with 12-minute warning. We'll get to the homework very soon. Okay. Yeah, you got a good point. But that's still going to have an infinite number of solutions. Would you agree with that? Okay, so it's not going to be like more than 2, but less than, it's still infinity. It's still an infinite number of solutions. It's a good example, and I didn't give it, and I'm glad you did. But my answer still holds that you're either going to get no solutions, or 1 solution, which you showed us, or 2 solutions, or an infinite number of solutions. Would you agree with that? Okay.
What would you write? Because like it's not all reals. It's just.
I get what you're saying. It's not all reals, and we're not going to give you that weird of a case. There, you're just preventing me from giving you that on the test because you don't have to worry about that one because we don't have time to worry about it right now. All right, so we're going to move on because I got to get you to your homework. On the next one on this page, I started it for you, but I need you to finish number 16. I think you get number 19 after I add absolute value of x plus 2 to both sides. Is just the same thing as number 16. So we're going to skip number 19, and if you want an extra practice problem for the day before the test, because like I never got those 2 absolute value kind, you got an extra practice problem right there. For right now, I'm just assigning number 6. I'm happy that you're asking such good questions that I want to stay and talk about them, but all right, on that page. On this page, I think this would be good for you because this is typically an R3 type question where we'll say, or maybe even R2 if there was only a couple parts of it, where we make you remember how to do the x-intercept. Hint, it's where y equals 0. The y-intercept, hint, it's where x equals 0. And the domain, once you graph it, you'll easily see from left to right. Range, up and down. Increasing interval, ooh, it'd be really nice to know where the little thing makes its turn so you can know where it's increasing versus decreasing. So anyway, we should do number 22 as a good reminder of a lot of basic size assignment. And that's all I have for you for the video for today. And I think that's it. I'm going to simply stop there. I think